Okay, this project came out a lot better than I expected, so that's great because sometimes my Arduino projects don't come out quite as planned. But this one actually I did pretty well, and the thing does kind of exactly what I wanted it to do. So so far so good. So the old setup I had was just the temporary kind of thrown together bank of resistors with an analog amp meter and a shunt on it. Need to get that organized, so make it much cleaner and more reliable. And also I wanted to include some over voltage resistors. On the left there you can see there's some blue resistors. Those are the over voltage resistors there, and those will be controlled by the charge controller using this mechanical relay. And those resistors are in series at a total of 20 ohms. So new stuff. The new solid state relay. This is a 150 volt at 60 amp solid state relay used for the dump load. That's going to be an upgrade today. And also these guys, another 4 300 watt 3 ohm dump load resistors. So that makes 1200 watts, adding to the existing 4 resistors at 1200 watts to bring the total to 2400 watts. The reason that we're doing that is because I had a little bit of a failure here. This is the 1800 watt PMA that was up on the Turbine, currently replaced with the backup PMA that's 850 watt one. And this was a failure based just basically because of my error. I wired the dump load incorrectly and I burned this thing up. So ordered a new one, and you can see this is the I think it's Thermodyne. And I went to the same place and bought a new one. This is the new one, and this is a 48 volt, 3-phase. You can see there's the 3 wires there. 3-phase AC, 48 volt PMA. That'll be coupled with the original tail and mounting hardware and the hub and blades that came from originally from Missouri Wind and Solar. And this is their Max Core, which is an upgrade over the previous, I can't remember, Super Core or whatever the previous one was. So, finished product here. All 8 resistors in place, all wired up in series and parallel to give it 2400 watts and roughly 6 ohms resistance. And also the over voltage resistors are in place and wired up as well. You can see the resistors in the bottom there and in the top on the temperature sensor connected to the Arduino is actually below that bottom row of green resistors on the right there, and then the blue resistors there wired in series, as you can see there. Those are 5 ohm resistors, so that it's a total, no, those are 10 ohm resistors, I'm sorry, that's a total of 20 ohms. Okay, so a couple of updates for the code. So now it says off when the duty cycle is at 0, which is cool, and it also says full when the duty cycle is at 100%. And I've also got a high temperature there now, so it'll keep track of the daily high, and you can see it's going full there. And that full is just when the duty cycle is at 100%. So it keeps track of that high temperature daily value there, and it's working pretty well. If anybody's interested in how this whole setup is wired, I'm going to actually do a video separately about the whole setup with a little bit more detail on the technical stuff. On how to set it up and what equipment I bought. But there's the schematic right there if you're interested in how mine is wired up. But I'm going to do another video pretty soon detailing the whole project and every component.